I'm Alevir Eddy, your host. I had an update for this part. I'm your host. And damn, I forgot. I was getting up from bed and I thought, oh, I'll add that. I'm your host, and I forgot what. And signals. Let's keep this thing rolling. Just scratching this. Week 1. Hey, no speed running. Learning game development without speed running. Going to the letter by letter. Getting that sync in the head. So this is me recording my learning process, but also doing, I think, some useful commentaries. I myself have a not super great coding skills, but I've been there. I've done a couple projects successfully completed. User interface, JavaScript, Android app development, backend, PHP, different disciplines. So using signals in this lesson, we look at signals. They are messages that nodes emit when something specific happens to them, like a button being pressed. Other nodes can connect to that signal and call a function when the event occurs. Signals are delegation mechanism built into Godot that allows one game object to react to a change in another without them referencing one another. Using signals limits coupling and keeps your code flexible. For example, you might have a life bar on the screen that represents the player's health. When the player takes damage or uses a healing potion, you want the bar to reflect the change. To do so in Godot, you would use signals like methods callable. Signals are a first-class type since Godot 4.0. This means you can pass them around as method arguments directly without having to pass them as a string. What? Like methods callable? Signals are a first-class type. They're a type of a first class, which means you can pass them around as method argument directly without having to pass them as a string, which allows for better auto-completion and is less error prone. See the signal class reference for a list of what you can do with a signal type directly. See also, as mentioned in the introduction, signals are Godot's version of the observer pattern. You can learn more about in-game programming patterns. We will now use signal to make our Godot icon from previous lesson. Move and stop by pressing a button. For this project, we will be following the Godot naming conventions. GDScript naming convention. Classes nodes use Pascal case, variables and functions use snake case, and constant use all caps. So when we see a all caps, it's a constant. It's inbuilt. Can it be custom? Scene setup. Okay, so setting up a new scene. To add a button to our game, we will create a new scene which will include a button and the sprite 2d.tscn scene we created in the creating our first script lesson. Create a new scene by going to the new menu, scene, new scene. Need to moist my throat like this. And to get the camera clear, remove the filter, pixel art in OBS. New scene. In the scene dock, click the 2D scene button. This will add a node 2D as our root. New scene, okay, and scene dock. For that new scene, also add a node 2D. Wait. New scene. Okay. In the file system dock, click and drag to onto the node 2D. Okay. So up to this point, I'll do up to this point. I'll repeat this. So I need to save this. Save. And here say new scene. Is this the one? It's empty, yeah. And I will just make sure that I can see. I will go into this because I need to see this. I remove this distraction field like a pseudo full screen for the editor, so it shows me this panel, because I enlarged this viewport for the script, so I have the long lines. I can read the long lines in the zoomed in like this. This is empty scene, and in it, so I have this on just to make sure that the viewport corresponds to this new scene. I'm adding in this new scene a 2D scene. I'm following this right properly. In the scene dock, click to do this 2D scene a node. So scene a node, create a root node. Okay, it is empty. Okay, I understand. I guess I understand this. But it is important to. I want to be certain. So add the scene dock. Add a 2D scene. This will add a node 2D as our root because it is empty. So when creating a new scene, it doesn't have anything predefined. I need to get a root tree going, node tree going. And that tree will be based on the 2D scene node. And then I can drag in it. I will drag in it. Drag at it the previous scene. We want to add another node as a sibling of sprite 2D, and on it I will add a child node. Okay. Which node? Button. Okay, we'll deal with that. So up to this point, so I'm adding in this new empty scene to the scene node, and I'll drag from the file system of the project this thing. It is in there. Cool. Can I zoom out and reposition the viewport like this? Zoom out so it fits the gameplay area. And right click over here on the imported instantiated scene. Add the child node, which will add a button. Where is it? Super tiny. I zoomed in with mouse wheel. Notice small by default. Click and drag on the bottom right handle of the button in viewport to resize it. If you don't see the handles, ensure the select tool is active. So use the scene toolbar to select tool. Click and drag on the button itself to move it closer to the sprite. How much closer? You can also write a label on the button by editing its text property. Enter toggle motion on the inspector on the right. So make it look at the end like this. Okay, let's do it. Let's do it. I can zoom out. I've got the select tool, move tool enabled. And in the end, what I want all it to look like is something like this. And I move this like here. Resize, scale. I don't want proportionally. Select, and I check this thingy like this. And on the inspector tab, text toggle motion. Motion. Cool. Can I get this larger? Toggle motion, what's this? No, I don't need to write an essay. Be directional, I guess BD. Text directional language. Layout, localization, tooltip, focus mode, theme, visibility, ordering, texture, material, process. The button, what's this? Properties, documentation, icon, la. I'm looking just for the decoration styling, but I'm guessing that's in the theme section. Theme empty, so I'm supposed to, where do I get the theme? Create a new theme, I don't know. There was one 3D game tutorial used the theming for user interface. But here we go, okay, we have here something like nothing. Okay, type variant. Can I get the system fonts from the installed on my computer, or I need actually to provide them in the project? Get the font file and use it to do those kinds of styling. Anyway, we got this looking something like this. Save your new scene as a node 2D. Okay, if you haven't already, You can then run it with F6. At the moment the button will be visible but nothing happens. Okay. Connecting signal in the editor. Here we want to connect the button's pressed signal to our sprite 2D, and we want to call a new function that will toggle its motion on and off. We need to have a script attached to the sprite 2D node. We need to have a script attached to the sprite 2D node, which we do from the previous lesson. Okay, we have that script attached. You can connect signals in the node dock. Select the button node, and on the right side of the editor click on the tab name node next to inspector. The dock displays a list of signals available on the selected node. Pressed. Filter signals. Double-click the pressed signal to open the node connection window. From signal pressed, connect to script. Receiver method on button pressed. Advanced connect. There you can connect the signal to the sprite 2D node. The node needs a receiver method, a function that Godot will call when the button emits the signal. The editor generates one for you. By convention, we name these callback methods on node name, signal name. So on button pressed. Here it will be on button pressed. So convention naming is the on node, which is button, signal name pressed. Pressed. Okay, so this is the signal. So node name, signal pressed. Got that? Super important. Note, do I go through the note when connecting signal via editor node dock? You can use two modes. The simple one allows you to connect to nodes that have a script attached to them and creates a new callback function on them. 2D, add extra call argument from signal. The advanced view lets you connect to any node and any built-in function, add arguments to callback, and set options. You can toggle the node in the Windows bottom right by clicking the advanced button. Okay, so here is the advanced. Another note, if you're using an external editor such as VS Code, this automatic code generation might not work. In this case, you need to connect the signal via code as explained in the next section. Next section is connecting a signal via code. So, and now we'll do it via editor. And button, node, signal, pressed, double click. Be persistent to double click to open it. I don't know what's my sensitivity on the button, or is the button too old, but here it is. Connecting from sprite 2D. Okay. And button press. So let's connect. We are connecting button connecting from to the sprite 2D. And I don't need the script, but I need this view. So here's the signal. And here's the sprite. So what's next? Okay, it jumps to the script workspace. You should see the new method with a connection icon in the left margin. Let me double check that that's the fact. So it did change to my. Let me see. Can I? Okay, let's go to the script. Where is the signal? Where is the method? Okay, here is the... I can follow the methods, implemented methods here. It's on the bottom. And for my... So I can reuse this and relearn this from this example lesson. I can say connecting signals connecting signals, and I'll put in the parentheses like a from node signal naming it from node and I'll give myself more room here to work and switch to browser. Nice. Do I have these things? So if I click the icon, a window pop-ups and displays information about the connection. So if I click this, I'll get this. Connections to method, button pressed, try to. Would you look at that? Let's replace the line pass keyword that toggle the node's motion. That'll toggle the node's motion. Let's... okay, with the code. I will implement this code. Cool. Our sprite 2D moves thanks to code in the process function. Godot provides a method to toggle processing on and off. Node set process. Okay, node set. Another method of the node class is processing. Returns true. So is processing this format, this type of expression, naming the methods like this with like a logical notion is means that it'll probably return a boolean, true or false. If idle processing is active, we can use the not keyword to invert the value. Function on button pressed, set process not. Set not is processing. Okay, so is processing. This function will toggle processing and in turn the icon's motion on and off upon pressing the button. Before trying the game, we need to simplify our process function to move the node automatically and not wait for user input. Replace it with following code which we saw 2 lessons ago. Again, your complete code should look like this. Okay, but what I'll do, jump to the editor. What are we saying here is was there a if? No. Processing, not processing. On button pressed. Set process. Okay, so right away set process not. If is processing returns. Okay. So just calling two methods. Calling two methods, setter and It's not, this is not a getter, it's just state. Query the state of a node. So it's not an if, it is I'm setting processing, set process to not querying the current state is processing like this. And if I just double check this, what will this, can I operate on this node? It's just list, okay. I will test this because I'm curious. Okay, I have two scenes now. Okay. I'm not ready yet. I didn't save this. Which is over here below. And I guess this screen smaller. Okay, so this was required. So I can now run this thing, and if I try to move, oh, it's moving everything. Wait, why would this be moved? If I hit toggle, it doesn't respond. Okay, so I cancel the user input. Is this supposed to be this way? Turn everything around. Do I have the right structure? You know what's going on? We got the label, the button as a child node of... so if I go back to the beginning, adding a button, no, I don't need, wait, they're silly. Drag the sprite to the node. We want to another node as sibling. Oh, a sibling, not a child. Okay, so I just need to move. Okay. I can try to rearrange this and do this like this. Can I just move it over here below? Does it matter is it below or up? Like this. Now it won't turn. It's a sibling, not a child of a sprite. It did cross my mind, but I ignored it. I thought now I move, toggle motion, block the move, and re-enable. Block, enable, re-enable, enable. Cool. Well, so fixing this, what I've messed up in earlier, fixing this is just simple as drag and drop, arrange, rearrange here. Here I just rearranged. I pulled the button from, added it as a child instead of the next child node to root node. I created it as a child node of a sprite. That made it replicate the movement of a sprite actually. Wrong, don't do it. Next thing that's fixed, cool. Adding a signal, okay, let's go, function, okay, process, so, and now we want to automate, okay, we'll go back to automation. Before trying the game, we need to simplify our process to move the node automatically and not wait for user input, replace it with the following code, which we saw 2 lessons ago. So use the previous version. So it's rotation, angular speed delta, velocity, rotation, speed, no direction in this version. So if I do like this and expand this, close this output, process delta. Now it's, since this is code now a bit larger, I could maybe use the, no, don't do that. Don't open the documentation. Rotation speed delta, angular speed. I'm supposed to replace complete function. Radial movement. We don't change position. Do we change the position here? What's going on? Yeah, it moves the position, so it's pretty much the whole deal. So how would I enable previous version and cancel out this version? I'll keep the player input, so I can disable this player input because I didn't delete any code. I didn't delete any code. I left it because here is even this thing, so I can re-enable it just by removing comments, and this thing will be like this. What is not matching the indentation level? At 121, okay, I need to comment these things. Cool. And we need this enabled. So automation, rotation, angular speed delta, position. Let's see. I could also create, clone the whole rotation. Yeah. This at the first glance, I've enabled the right lines, so rotation and the previous version of this. Maybe a better thing would be like, it would be even, now, here would be the next step for me to implement. Have these two modes of gameplay, implement selection for to switch between these two gameplay modes. That would be a good exercise without intervention in the code. Have both codes, function versions available, and put in the user interface a button for for player to select a game type, and we should be able to run this. Save, run the scene. He's moving on its own. Toggle stop, like that. So what I'll do in this, for the exercise, this is what I'll do here. I will add in my code on top. On top, I will add a line to do implement game modes, switch between auto move movement and player input to control character. I'll just ident this a bit more and say this is this section, let's say. Save this, and now next lesson. Next, there's enough time today to do 2 streams. I'll close this using signals, and after that maybe go again through the first 2D game. Maybe I'll go through the first 2D game tutorial with all this knowledge learned, and I can do some my own implementation, because now I know what's going on. If you just follow the tutorial, you don't know what's possible, what's not possible. Now I know connect signal via code, complete script, custom signals via code. You can connect signals via code instead of using the editor. This is necessary when you create nodes or instantiate scenes inside of a script. That's my I like that even better, because script is like a script in the usually, like if in the for a screenplay, a movie script, or a scene theater play, there is a script also, and it's written human readable language or any other language, as the standards for the industry describes. And if I have all game logic or a lot of game logic in the editor actually appears flat, and it's hard to read what's the intended to happen. You need to check, click around, and check for what's connected with what, with signals, how. But if it's possible to, if I have everything, if I can manage everything in the code, I can always read that one script code in the script and read how to direct the game, how it will play out, written in the script. It's better readable, better insight of the whole project, whole game, whole elements and logic implementation. Let's use a different node here. Godot has a timer node that's useful to implement skill cooldown times, weapon reloading, and more. Head back to 2D workspace. You can either click the 2D text at the top of window, okay, Control F1, in the scene dock, right click on sprite 2D node and add a new child node. Search for timer and add corresponding node, timer node. Your scene should now look like this, sprite timer. With the timer node selected, go to inspector and enable the auto start property, auto start on. Click on the script icon next to sprite 2D to jump back to the scripting workspace. We need to do 2 operations to connect the nodes via code. Okay, let's first add the node. I need to go out of this. Right click here. Select it. Add child node, timer. Timer, yeah. typing filter out, and in the inspector auto start on. Nice. Sprite, click here on the, I'm clicking on the script to jump. Well, actually I wasn't even in the, I've stayed in the script. We need to do two operations to connect the nodes via code. Get a reference, references, to the timer from the sprite 2D. Call the connect method on the timer's timeout signal. Two things to do. So this is to do. To connect to a signal via code, you need to call the connect method of the signal you want to listen to. In this case, we want to listen to the timer's timeout signal. We want to connect the signal when the scene is instantiated, and we can do that by using node ready built-in function, which is called automatically by the engine when the node is fully instantiated. To get a reference to a node relative to the current one, we use the method node get node. We can store the reference in a variable. Like, oh, I like this. I like this. Super cool, super cool. The function get node looks at the sprite 2D to these children and gets the node by their name. For example, timer. Okay, let's implement this function ready and instantiate timer, where we'll keep a reference to the node timer. Give me this. Let's say I do this here. Function ready. Is that it? Ready? Variable timer, local variable. It's not wet, it's var. Timer equal get node timer. Yeah, it also provides me the auto completion. For this I hit save, I'll tap to the code, to the page. The function get node looks at the children. Okay, get node time. Oh, I like this so much. For example, if you renamed the timer node to blinking timer in the editor, you will have to change the call to get node blinking timer. The function looks at the sprites and gets the node by their name. We can now connect the timer to the 2D sprite in the ready function. We can now connect. Come on, don't jump around like this. Sorry people about this, but okay, we can now connect the timer to the sprite 2D in the ready function. Okay, there's an added now timer.timeout.connect on timer timeout. The line reads like so. We connect the timer's timeout signal to the node to which the script is attached. Okay, so node is timer and the signal is timeout. When the timer emits timeout, we want to call the function on timer timeout that we need to define. Let's add it at the bottom of our script and use it to toggle our sprite's visibility. By convention, we name these callback methods in GDScript as onNode name signal name. onNode name, signal name, and C# is as on node name, signal name. Here it will be on timer timeout, okay, for GD script, and on timer for C#. Timer timeout connect on timer timeout. So I'm node is timer, which is in variable timer. I like it, so it makes more sense. Follow the logic of it. Variable timer. So in timer, connect. Give me the time. No timer, timeout. I already forgot. Yeah, time. Okay, so that signal connect and pass it the name of the function. Actually, pass the okay. So we are passing the method to the call of this callback function. Okay, now I even better now understand this than in JavaScript. Callback, promise, and what was the other term? Timeout, connect, and provide method on timer timeout. Don't worry. Did I get this properly? So the warning in code actually throws an error, but it's actually reminding me to complete this implementation, what you're up to. Visible equal not visible. The visible property is a boolean, so what's intention here? The visible property is a boolean that controls the visibility of our node. Okay, the line visible equal not visible toggles the value. So I'm reading from here. Timer not visible equal not visible. So it's a property. Visible is a member of a node. The line visible toggles it. You can run now and you'll see that sprite blinks on and off at 1 second intervals. Complete script and custom signals. How much of that there is? Okay, that will be. I'll just have a tiny break and finish this stream with the custom signals. And this is done. I just need to implement the function on timer, timeout. Copy, go, function, this thing, okay, pull down, variable, no, method, it already exists. Visible equal not visible. Was that it? Huh? So the operator works like that. Okay. Well, let's check how my thing will blink. F6, blink 1, 2, blink 1, 2, toggle motion, blink, blink 1, 21, 21, and toggle motion, blink, blink, blink. Okay, I love it, I love it, love it. What would I say here? So function ready. Okay, okay, so this is I know what I'll say here. This section is connecting signal in code with code okay, and I'll do this and copy this. Is there a line more? No. Like this. Save. Should breakity break. Switching to the outro. Stay safe. See you soon.